The mind-blowing, the deadly secrets of a place we call the universe. Where are the Martians? On the red planet's poison-packed surface? Or in newly found sources of water? Did Martian life survive an apocalyptic attack? Are Martians microbial or monstrous? At last, the answers are here. In Mars, the new evidence.
I believe we can send humans to orbit Mars and return them safely to Earth. And a landing on Mars will follow.
When we land on Mars, there may be billions of Martians waiting for us. Only they probably won't look like this. Or this, but like this. Microbes, bacteria evolved to survive on a planet with 1% of Earth's atmospheric pressure. An arid world where temperatures can plunge to 220 degrees below zero.
Now, even if that upper surface is so nasty, that doesn't mean that just a little ways under the surface wouldn't be a much happier place for microbial life on Mars.
Is there life on Mars? Just a decade ago, my answer would have been very different than it is today, because we've learned so much.
A few decades ago, it would have seemed like science fiction. But we now know that on Earth, some bacteria cluster around thermal vents at the bottom of the sea. Others thrive in pockets of liquid water inside 12 feet of Antarctic ice.
Our knowledge of microbial life on Earth has increased so much that I think, there's still a good chance that some kind of primitive life may have formed on Mars and existed there at some point.
How could life have first formed on Mars? Maybe with a flash of lightning. The spring of 2006. Even as some scientists are claiming Mars doesn't have lightning, Earth-based microwave detectors find it in friction-filled storms of red dust.
But it's not lightning like we know it, associated with rainstorms. It doesn't rain on Mars. It's what's called dry lightning.
And this dry lightning, or static electricity, could have been the trigger for Martian life.
Once you have lightning, you've got a new source of energy that can affect your chemistry and alter things in the atmosphere, even on the surface at some level.
A famous experiment seeking to replicate the creation of life on Earth ran an electric current through a mix of water and common gases, creating a soup containing organic compounds and the building blocks of life, amino acids.
By hitting things with electrical discharges, you can not necessarily generate life, but maybe make the preconditions for life.
But did dry lightning help jumpstart life on Mars? Or did it kill the chance for any life at all?
Lightning on Mars could create things like hydrogen peroxide, which could then lead to other chemicals that would destroy organic material and sterilize the surface.
Life-giving jumper cable or fatal electric chair? The jury is still out on what dust storm lightning has done to Mars.
But what always happens with Mars is about the time we think we understand it, we discover new things that make us realize we still have a lot of mysteries to solve.
So how do you find bacteria too small to be seen, living under the surface of a planet 48 million miles away.
The life that's most likely to be prolific, the life that you'd find the most number of organisms, if they did exist, is the one that's hardest to find of all.
Like climbers, scientists look for life on Mars by making connections, linking this observation to that deduction, hoping the evidence leads in the right direction. And if the facts aren't there, you start over.
It's hard to look for life, so the mission designers have said, well, let's first figure out if there are habitable places, if there are places that would be friendly to life.
And the key element for life as we know it is water.
On Earth, liquid water is required for life. Even if it's a small pocket in the heart of a glacier, you still need the fluid nature of water for the processes of life to take place.
According to early space probe photos, Mars was just a dead red rock. Its thin atmosphere was mostly carbon dioxide. And so it seemed were the polar ice caps.
You know, in the 70s, we might have expected that there was no possible water or life on Mars. The picture is much different today.
In the 21st century, more advanced space probes have revealed that a lot of the earlier information was wrong. It turns out there's about 100 times as much H2O in Mars' polar ice caps as in all 5 of North America's Great Lakes.
So even in the polar caps today, there's probably enough water to cover the surface, about 20 or 30 feet deep. But it's really not about whether we think there's water on Mars, but whether there's liquid water on Mars.
That's the key question, because even microbial life could not have evolved on Mars unless there was liquid water early in the planet's history.
In order to find liquid water on Mars, we actually look in a whole variety of ways.
From 1997 through 2006, NASA's Mars Global Surveyor searches for water-based minerals using a highly sensitive spectrometer.
Every chemical element has a particular signature associated with it, a sort of fingerprint. And when light interacts with it, it re-emits that light in a very specific way that's characteristic to that given element. And so that's telling you what things are made of by just looking at the light they emit.
It's similar to the way the human ear can pick out specific vibrations.
Some notes boom out. Other notes are not so loud. In much the same way, spectroscopists are interested in selecting out those particular lines.
The Surveyor spacecraft hit spectrographic pay dirt. Hematite, a combination of iron and oxygen. Hematite shows that ancient Mars could have had flowing water because the mineral is also found on Earth in environments that once interacted with liquid water.
These round rocks from Utah, they formed in a sandstone by fluid water flowing inside the pores of the rock and moving iron around so that the iron actually cements together these little spheres. And the ones on Mars are quite a bit smaller than these, but they're thought to form the same way.
The Surveyor's mission is over, but today 5 probes are taking pictures and measurements of Mars. Europe's Mars Express circumnavigates the equator. NASA's Mars Odyssey and the more recent Mars Reconnaissance Orbiter, or MRO, soar over the poles. Meanwhile, 2 robot rovers explore the surface, seeking evidence of ancient water in the rocks.
Spirit is in a very hilly, rocky dusty, rugged kind of place. It's very sort of reddish and bright when you see the pictures from that rover. Opportunity on the other side of the planet is in a very flat place, darker, more kind of a chocolatey brown color than a reddish color.
In the spring of 2008, the 5 probes are joined by a 6th. NASA's Phoenix lander. May 25th, 2008. As anxious men and women on Earth watch their monitors, the Phoenix lander ends a 9-month space journey, flaming through the Martian atmosphere at 12,500 miles an hour.
We taught the baby to fly, you know, we gave him all the wisdom, and now we have to let it go and do the job.
Any landing on Mars is incredibly difficult, and the chaos happens within 6 or 7 minutes, from the top of the atmosphere to the surface.
We call it the 7 minutes of terror.
That's how much time Phoenix has to cut its descent speed from 12,500 miles an hour to 5. If not, Mars will have one more impact crater.
Years of effort is being tested whether it's going to happen or not.
The parachute deploys. Caught live by the Mars Reconnaissance Orbiter. Thrusters slow the plummet for a near-perfect landing near Mars' North Pole.
Touchdown signal detected. Medium range detected.
Phoenix will search for frozen water under the surface. But has it already found more than was expected? A photograph of one of the lander legs seems to show something that should not be there. There is new evidence that Mars could once have supported life. Mineral deposits show that water once flowed on the surface. NASA scientists look for evidence of water wherever they can find it on Mars. But in the spring of 2008, they may have found it in an unexpected place. The Phoenix lander, newly arrived near Mars' North Pole, has something strange on one of its legs.
Some colleagues think that those are water droplets forming in that environment, which is a little curious because it's very cold. It's not at all obvious that water should be stable there, but it could be really salty, could be briny, and so it has a lower melting point. That's possible.
I don't know what the blob of water on the Phoenix lander leg was, or the thing that looked like that.
Scientists are split, and internet blogs run wild with speculation. But in the end, it's all speculation.
The unfortunate thing is, the data that we have are really kind of fuzzy, right at the limit of resolution. You really want to go up there and take a much better picture of it, but it may ultimately be a question that can't be answered.
Although the droplets on its leg remain a mystery to this day, when Phoenix's robot arm digs 2 inches under the Martian surface, it confirms a prediction. As it hits hard, icy soil containing frozen water,
Mars Odyssey predicted that Phoenix would land on an icy soil with a little bit of dust on top.
Phoenix went, touched it. We got another key part of planetary science, which is getting ground truth.
While the Phoenix team expected water ice, they're surprised by something else the lander's laser detects in the Martian sky. Snow. Not carbon dioxide snow, but water crystals, as on Earth.
It snows on Mars, which is indeed cool. Phoenix saw it first dissipating high in the atmosphere and eventually actually falling to the surface, and then sublimating and going back to a gas when the sun came back up. It really is one of the first times we're really seeing the surface atmosphere water cycle. In this case, gas to solid, solid back to gas.
Meanwhile, roving robots explore near the equator. Spirit and Opportunity use high-resolution imaging and spectroscopy to find evidence of minerals and landforms shaped by water in Mars' ancient past.
Day in the life of a Mars rover starts as the sun rises and illuminates the solar panels, and that wakes up the rover. The radio commands are sent from the Earth to tell it what to do. This time, drive 10 meters forward, and then stop and turn 20 degrees, and then take a panorama with these color filters looking off in that direction. Near the end of the day, one of the NASA orbiters, like the Mars Odyssey orbiter or the Mars Reconnaissance orbiter, is passing overhead, and we know when that's going to happen. The rover will transmit data from that day up to that orbiter, and then that orbiter relays it back to the Earth. And while it's sleeping, we've got those pictures that it just sent back and other data, and now we're trying to figure out what happened. Did it do what we were expecting it to do? Did it do something unexpected? Is it in some dangerous situation?
In early 2008, signals from Spirit indicate trouble. Its right front wheel jams. When the Phoenix team tries driving the rover in reverse, the dragging wheel gouges several inches into the soil and hits silica.
On our own planet, where do we find silica? Well, hydrothermal environments. Maybe that's what we're seeing on this other world as well. So a lot of the excitement about silica is because of that connection to our own planet. That indicates that, hey, maybe those kinds of environments existed on Mars as well. In fact, the Spirit rover may be parked at one right now, right next to it, what may have been an ancient Yellowstone-like hotspot.
It's a classic accidental discovery and raises the question, could Mars have current underground thermal activity?
Is Mars still hot in its interior? It certainly is. There's no way that Mars has completely cooled off all the heat of its accretion, all the heat of its formation. Some of it is still there, plus heat from radioactive elements. There's definitely sufficient heat inside of Mars to make hot fluids percolate, but there is that possibility where you might find liquid water at some depth in the crust, yes.
In Yellowstone and at hot springs all over Earth, many different species of bacteria feed and grow in the gas and mineral-rich waters. Could hidden hot springs be breeding grounds for life on Mars?
We would love to send electromagnetic sounding instruments to the planet because they could actually tell us whether there is liquid in the crust at some depth. That would be fantastic. Then we'd know.
While the Spirit team wonders about Mars' underground mysteries, the Phoenix team finds another surprise on the surface. 2% of the soil around the Phoenix lander is composed of perchlorates, combinations of chlorine and oxygen.
The discovery of perchlorates on Mars has been fairly controversial because on Earth it's a very toxic substance.
On Earth, perchlorates are used as propellants in fireworks and rockets.
This was a surprise. This was a discovery. Why is it even there? How is it forming? The question of perchlorates is a really good question, and there's no definitive answer.
Perchlorates do occur naturally in places like Chile's Atacama Desert, as ultraviolet radiation from the sun transforms chlorine and oxygen.
And on Mars, many of the same kinds of chemical reactions might be happening on the surface. We don't understand the details of even on the Earth, let alone on Mars.
The other challenge with perchlorates is they affect some of the experiments that people use to look for organics, for carbon-based molecules like you might find in life.
some scientists are now reconsidering the famous 1976 experiments by the Viking lander.
When Viking went to the surface in 1976, they found no evidence whatsoever of organics. One of the recent theories that's being bandied about is that if you did have perchlorates in the soil, that those might have actually broken down the organics in the same process that you were using to try to detect them as you heated the soil up.
Perchlorates may have destroyed organic materials in the Viking experiment. And on Earth, they're a key poison in many chemical runoffs. But perchlorates are also power sources for certain bacteria. Bacteria actually used to eat toxic wastes.
And in terms of life, it's a good news, bad news thing.
While microbes might feed on the toxic soil, it could be deadly for humans on Mars.
We don't know how that perchlorate compound might be changing the surface. The surface might be in some kind of a superoxidated state that could ultimately prove to be, for example, corrosive to astronaut suits.
One thing is certain. After 5 months of exploration, Phoenix's mission is threatened by a dust storm sweeping across the Martian plains, burying everything in its path. In a storm so fierce, the Phoenix lander is doomed. When NASA's Phoenix lander digs into frozen water on Mars, it finds new evidence that the red planet could once have harbored life. But in the autumn of 2008, Phoenix's own life is about to end.
On Mars, the wind comes along and whips up the dust, which is very, very fine-grained, like flour, extremely fine-grained material, whips it up into the atmosphere, and it slowly settles out, blanketing everything.
Red dust coats the solar panels of the Phoenix lander. Sunlight, its only source of power, can't get through.
The Phoenix lander has to spend a lot of time recharging its batteries because we know that it's going to get very cold at night and it's going to have to run those heaters at night to stay alive.
On November 2nd, 2008, Phoenix shuts down for the last time. As the Martian winter deepens, frozen carbon dioxide piles up and imprisons the probe in a tomb of dry ice. But Phoenix's data continues to be analyzed.
Going to Mars and taking measurements on the surface, getting detailed data about the history of Mars and Mars chemistry of the surface was an essential piece to determining for sure that water existed on Mars.
Water is essential to life. But according to the latest evidence, it's only one of many forces that shaped Mars.
You can kind of break down our thinking of Mars now into maybe like 4 quarters of a football game.
The first quarter, from about 4.6 to 3.2 billion years ago, is action-packed. Mars forms along with the other planets as swirling gas and debris combine and cool into a rocky world. Then, Mars is bombarded and scarred by meteoroids.
There was a lot of cratering going on, and then towards the end of that period, there was a lot of geologic features that suggest that there was water flowing on the surface.
That new evidence includes this series of ridges, photographed in 2009 by NASA's Mars Reconnaissance Orbiter. It's the first definitive lakeshore discovered on Mars. The remains of a lake the size of North America's Lake Champlain.
Every piece of evidence about the presence and the history of water on Mars is so important to determining whether we might be alone in the universe.
Some scientists even say that 3.5 billion years ago, an ocean the size of the Atlantic covered 1/3 of Mars.
Maybe with enough time and enough water, life formed on Mars as well.
As the first quarter of Mars history ends, the second starts with a bang. As volcanoes reshape the planet.
There was significant volcanic activity. Olympus Mons is the biggest volcano in the solar system. So we know there were big volcanoes in the past.
Mars is blanketed with black volcanic basalt, like the basalt found around Hawaiian volcanoes.
And the chemicals released from volcanoes, including sulfur, mix with the water that was left and make things acidic, kind of like acid rain on Earth and that sort of thing. At the same time, the atmosphere seems to be shrinking and water becoming more scarce and less stable on the surface.
The loss of Mars's atmosphere meant that liquid water could no longer exist on its surface. Water exists on the surface of the Earth only because of the atmospheric pressure pushing down on it.
Whatever water is on Mars evaporates or freezes. In the third quarter of its history, Mars probably begins turning red from ferrous oxide. Rust in the dust.
Take a fresh volcanic rock in Hawaii or Iceland and let it sit out in the Earth's atmosphere, and it's going to turn red and brown over time. It's going to oxidize. Same kind of thing could have happened on Mars.
In its final quarter, Mars goes into a deep freeze. From around 100 million until 2 million years ago, large glaciers form and carve out new patterns in basins and craters. From a warmer, wetter planet to a cold, dry world. Mars in a nutshell, according to recent evidence.
It had a thicker atmosphere, it had water, it may have had rain, it had snow, it has all kinds of things that are familiar to us. And it's just fascinating to think that we can go back in time with these missions and study an early sort of Earth-like Mars that's now gone.
But while there's strong evidence for past water on Mars, these 2009 satellite pictures seem to show something impossible. Flowing liquid water on the surface.
There could be events when water that has been kept subsurface or frozen comes gushing out and runs down the walls of these craters.
This is one of the most exciting things in the past decade, is seeing those pictures of the gullies, because when I grew up, I was taught that there's no way liquid water could be stable on Mars today. And this kind of flies in the face of the physics, right? And that's kind of exciting, because it means that we might have something wrong.
The initial announcement of finding them proposed that ice that was melting or an aquifer coming up. There's a whole different set of theories and recent study that it could be from carbon dioxide, the dry ice going to a gas, and then that gas basically doing a gas lubrication of the sand that's flowing down. And frankly, it's still in the midst of exploratory science right now.
And some of these marks have been shown to be dust flows. I hope not all of them. I'd like them to be water.
From ancient oceans to yesterday's flowing gully, the search for water and life on Mars is an ongoing quest. A quest that, like a climber's path along an unfamiliar course, is filled with false starts and unexpected detours. That's what happens when this photograph, taken near the Martian equator, reminds a lot of people of this. Could Mars once have supported life? Mineral evidence from probes like the Spirit rover is encouraging, but it can be radically overinterpreted.
We have to be careful not to jump over a line that goes beyond what the current data, the current experiments, the current hypotheses can support. But it's hard as human beings not to just jump over that line.
In 2008, thousands jumped to an incredible conclusion when a picture taken by NASA's Spirit rover goes viral across the internet. Doesn't this figure look amazingly like pictures supposedly taken of Bigfoot? Is this proof of life on Mars? No. It's a 2-inch tall rock.
We still do not have definitive evidence for the existence of life on Mars ever.
Like the 19th century canals and the 20th century face, the Martian Bigfoot is a 21st century trick of the light.
And sometimes people don't know how to distinguish between the facts and the science fiction.
If there is or was life on Mars, it probably evolved very early in the planet's history, when Mars still had a magnetic field shielding it from harmful space radiation.
The evidence that Mars used to have a magnetic field lies in the crustal rocks. Most of the crustal rocks have a magnetic field frozen in when they solidify.
These magnetic rocks, scattered across the red planet, give Mars its own version of Earth's northern lights, as discovered in 2008, although it may not register as visible light to human eyes.
On Earth, when charged particles from the sun get trapped in Earth's field lines and smack into the atmosphere, they cause the atmosphere to gain energy and then emit a glow. The European spacecraft Mars Express recently detected aurora on Mars. And what's actually happening there is that there are charged particles streaming down magnetic field lines being made by remnant magnetization in the crust.
But how did Mars lose its magnetic field? One theory, a little less than 4 billion years ago, as Mars cools, its molten iron core solidifies and stops turning.
The motions within the core weren't sufficient to generate an electric current, producing a magnetic field.
But there is also a faster and far more violent hypothesis.
Another more recent idea that's pretty controversial is that Mars had one or more fairly large moons that were actually captured satellites. And those moons tidally heated the interior and kept it molten, allowing currents to be generated and thus producing a magnetic field. Now, if a 500 million years after Mars's formation, those moons crashed into the planet, that could have destroyed the magnetic field.
For most scientists, the pieces of the impact theory don't fit. Could satellites large enough to do such damage lose enough inertial energy to be captured in the first place?
This idea that Mars had moons that crashed into it within the first 500 million years is pretty unlikely, but it's not completely impossible.
Questions about Mars' magnetic field and the search for life intersect here. In the Martian meteorite ALH 84001. In 1996, some scientists say it contains fossilized Martian microbes. More scientists say the objects are non-biological.
All the time since then, people have been working on this poor little potato-sized meteorite, extracting more and more information. But there's actually has some new results being presented.
In April 2010, researchers with new radiometric tools announced that earlier estimates of the meteorite's age are wrong.
It's actually younger by 500 million years than we thought, roughly.
The older date had placed the rock at a time when Mars was still solidifying, maybe too early for even microbes to have evolved. The new date places the meteorite at just under 4.1 billion years old.
That, of course, is the time 4.1 billion years ago when, if you thought Mars was habitable, that would be the time you would choose. Because we think there was water flowing on the surface, and it was warmer, and it was a thick atmosphere.
But how can a meteorite from Mars end up on Earth? That's what Christina M. from Dallas, Texas wanted to ask the universe when she texted us, what makes part of one planet fly off and land on another?
Great question, Christina. We've actually found meteorites here on Earth that are undeniably from Mars. There's about 50 of them known. Well, what we think happens is that asteroids occasionally slam into Mars and throw chunks of rock out into space, and Earth's gravity can also pull them in. So they land here, and we find them, and in this way we can actually study pieces of Mars here on Earth.
In 2010, NASA announces that more advanced electron microscopy of ALH-84001 reveals new details of iron oxide crystals called magnetite, a mineral within its own magnetic field that on Earth can be created by certain ocean-dwelling bacteria.
Bacteria here on Earth have figured out how to grow magnetite crystals in their own bodies that help them to orient to the Earth's magnetic field in order to help them swim in the ocean and orient while feeding.
Are the crystals in ALH-84001 fossilized magnetite created by Martian bacteria to help them hunt and feed in an ancient ocean when Mars still had its magnetic field more than 4 billion years ago?
If they are fossils, of course, they'd indicate that early Mars had fairly sophisticated life.
That's still being batted about, and bottom line is there's still a heck of a lot of scientific work being done and a lot of debate about Mars meteorites and whether there's any evidence of past life in those.
But the latest and most compelling evidence of Martian life isn't in an ancient meteorite, but on Mars today, even though this new evidence is invisible. For years, scientists looking for life on Mars have followed the water, but there may be something to follow that's even more dramatic. Between 1999 and 2009, spectrographic observations of Mars detect a combination of carbon and hydrogen called methane gas.
The discovery of methane on Mars, in Mars' atmosphere, was a real surprise to people.
Plumes of the gas seem to be coming from a few hotspots during the Martian summer. The trouble is, there shouldn't be any methane on Mars.
On Mars, even just the presence of methane is a little bit mysterious because it breaks down.
On Earth, the unstable methane molecule disintegrates after about 300 years. But on Mars, high doses of ultraviolet radiation and perhaps the newly discovered dry lightning in the thin, dusty Martian atmosphere break the methane down in just a few months.
And so if you see it there, it means there must be something resupplying it. Even though it's being broken down, it's getting resupplied.
Where's the Martian methane coming from? On Earth, volcanoes produce vast amounts of methane. But even though Mars has Olympus Mons, the largest volcano in the solar system, it hasn't erupted for millions of years. So what are the other choices?
Methane can be produced underground when basaltic rock gets turned into a mineral called serpentine, and that releases methane, and that methane could seep up through the ground and come out in the atmosphere.
But this process requires hot liquid water, which hasn't yet been found on or within Mars.
Could be volcanoes, which we don't know to be active on Mars, so that would be interesting. Could be some subsurface chemistry with liquid water, which we don't know to be on Mars, so it would be interesting. Or it could be due to biology.
On Earth, 90% of methane comes from bacteria in animals and plants. Is the Martian methane coming from underground colonies of bacteria?
The discovery of methane on Mars led to headlines of us having definitively found evidence for life on Mars. And entire chat rooms were set up to discuss these various creatures. But in fact, though the discovery of methane is interesting, it doesn't mean that we found creatures wandering around on Mars.
Maybe it is life. It's an arrow to something, and maybe the thing at the end of the arrow is life.
The search for the source of Martian methane has become a priority for explorers and is on the mission list for the next rover to be sent to Mars.
So we're looking at a so-called test bed version of the Mars Science Laboratory rover. And the Mars Science Laboratory, when it gets down to the surface, will measure methane. So we'll know the answer once that rover gets down there.
The Mars Science Laboratory, dubbed Curiosity, will launch in the fall of 2011 and land in 2012. It's the size of a small car and will use an amazing new landing technique, the sky crane.
At about 60 feet above the ground, the rover is separated from the descent stage and lowered on a line, which we call the bridle, and slowly lowered to the ground and lowered to the ground. When the rover's wheels touch down on the ground, the descent stage detects that, it cuts those lines, and then it flies away and it crashes safely far away, and the rover is on the ground on its wheels, ready to go do its job.
The high-frequency radar, essential to the sky crane landing, is mounted to a helicopter and taken for a test drive at California's Edwards Air Force Base.
When you're coming down on Mars, we do a bunch of simulations and analysis to go ahead and give us bounds of what we expect to see in terms of descent angles, in terms of attitude rates on the parachute.
During the entry, descent, and landing, the radar tells us where the ground is and how fast we're going. That information is used by the control system to control the thrusters to make sure we touch down at a nice gentle speed.
We test little pieces here and little pieces there. So the first time that we tested for real is on Mars.
The key objective of the Mars Science Laboratory is to search for signs of ancient habitats. And so the rover will rove up to areas that had been soaked in water in the past and may have trapped organics. So if we find those kind of layers, we can go up to that kind of a rock and we can drill into it and take the material from inside the rock and tell with a lot of precision what the rock is composed of and whether there's organics in there.
The Mars Science Laboratory will be one more link in a chain of exploration to understand that bright red dot in the dark night sky. Put together all the new evidence, and it adds up to the need for more evidence.
We don't know how the magnetic field was lost. We don't know exactly how the atmosphere was lost. We don't know where all the water went. We don't know whether the methane is produced by life or just regular abiotic chemical reactions.
But maybe questions that baffled the 19th and 20th centuries will be answered in the 21st.
I asked 5 other Mars scientists, what percentage chance would each of you give that life ever formed on Mars? 4 of us thought it was maybe greater than 90% chance that there had been at some time, and maybe now, life on Mars. And 2 of us thought it was less than 15%. And the follow-on question then is, if you think that there's less than 15% chance, is it really worth going to look for it? And the answer was immediately, absolutely.
I don't think that rovers and landers and orbiters are going to find life on Mars. My personal opinion, I think it's going to take people. I think there will come a day when people go to Mars, digging and drilling and thinking and just going with context and gut feel and putting the pieces of a very complicated puzzle together. I'm optimistic that we're going to find evidence of past or present life.
The jury is still out on what dust storm lightning has done to Mars.
But what always happens with Mars is about the time we think we understand it, we discover new things that make us realize we still have a lot of mysteries to solve.
So how do you find bacteria, too small to be seen, living under the surface of a planet 48 million miles away?
The life that's most likely to be prolific, the life that you'd find the most number of organisms, if they did exist, is the one that's hardest to find of all.
Like climbers, scientists look for life on Mars by making connections, linking this observation to that deduction, hoping the evidence leads in the right direction. And if the facts aren't there, you start over.
It's hard to look for life. So the mission designers have said, well, let's first figure out if there are habitable places, if there are places that would be friendly to life.
And the key element for life as we know it is water.
On Earth, liquid water is required for life. Even if it's a small pocket in the heart of a glacier, you still need the fluid nature of water for the processes of life to take place.
We're claiming Mars doesn't have lightning. Earth-based microwave detectors find it in friction-filled storms of red dust.
But it's not lightning like we know it, associated with rainstorms. It doesn't rain on Mars. It's what's called dry lightning.
And this dry lightning, or static electricity, could have been the trigger for Martian life.
Once you have lightning, you've got a new source of energy that can affect your chemistry and alter things in the atmosphere, even on the surface at some level.
A famous experiment seeking to replicate the creation of life on Earth ran an electric current through a mix of water and common gases, creating a soup containing organic compounds and the building blocks of life, amino acids.
By hitting things with electrical discharges, you can not necessarily generate life, but maybe make the preconditions for life.
But did dry lightning help jumpstart life on Mars? Or did it kill the chance for any life at all?
Lightning on Mars could create things like hydrogen peroxide, which could then lead to other chemicals that would destroy organic material and sterilize the surface.
Life-giving jumper cable or fatal electric chair? But like this. Microbes, bacteria evolved to survive on a planet with 1% of Earth's atmospheric pressure. An arid world where temperatures can plunge to 220 degrees below zero.
Now, even if that upper surface is so nasty, that doesn't mean that just a little ways under the surface wouldn't be a much happier place for microbial life on Mars.
Is there life on Mars? Just a decade ago, my answer would have been very different than it is today, because we've learned so much.
A few decades ago, it would have seemed like science fiction. But we now know that on Earth, some bacteria cluster around thermal vents at the bottom of the sea. Others thrive in pockets of liquid water inside 12 feet of Antarctic ice.
Our knowledge of microbial life on Earth has increased so much that I think, there's still a good chance that some kind of primitive life may have formed on Mars and existed there at some point.
How could life have first formed on Mars? Maybe with a flash of lightning. The spring of 2006. Even as some scientists are the mind-blowing, the deadly secrets of a place we call the universe. Where are the Martians? On the red planet's poison-packed surface? Or in newly found sources of water? Did Martian life survive an apocalyptic attack? Are Martians microbial or monstrous? At last, the answers are here. In Mars, the new evidence.
I believe we can send humans to orbit Mars and return them safely to Earth. And a landing on Mars will follow.
When we land on Mars, there may be billions of Martians waiting for us. Only they probably won't look like this. Or this.
Place.
According to early space probe photos, Mars was just a dead red rock. Its thin atmosphere was mostly carbon dioxide. And so it seemed were the polar ice caps.
You know, in the 70s, we might have expected that there was no possible water or life on Mars. The picture is much different today.
In the 21st century, more advanced space probes have revealed that a lot of the earlier information was wrong. It turns out there's about 100 times as much H2O in Mars' polar ice caps as in all 5 of North America's Great Lakes.
So even in the polar caps today, there's probably enough water to cover the surface, about 20 or 30 feet deep. But it's really not about whether we think there's water on Mars, but whether there's liquid water on Mars.
That's the key question, because even microbial life could not have evolved on Mars unless there was liquid water early in the planet's history.
In order to find liquid water on Mars, we actually look in a whole variety of ways.